Alright, bro, if you think you hate discrete math, then this video is for you. Maybe you're taking a discrete math class right now and you're having a hard time with it. Maybe you haven't enrolled in one yet and are dreading the future. Maybe you already took the class and you burned your textbook after the final as a way to release all your pent up frustrations. Either way, if you're a computer science student, there's no avoiding discrete math. So you might as well try to develop a more positive mindset towards it, you know? So my aim with this video is to introduce to you a different perspective on the subject of discrete math in an effort to perhaps make it a bit more enjoyable for you. Yeah? Alright, so let's get into it then. Now, what even is discrete math? Basically, it's the study of things made up of parts you can count one by one. So if you've ever taken a calculus course, you'll know how we study smooth curves and continuous functions, right? But in discrete math, we study structures composed of distinct individual pieces. So these include integers, graphs, logical statements, and so on. But the reason we study it in computer science is because it's the mathematical language for computing. Whether you're building circuits with AND gates and NOT gates, or writing recursion into your algorithms, or even just using if-else statements in your Java code, all of it boils down to discrete mathematical structures. So what we do is we discover and study properties about these structures. And in order to conclude these properties with absolute certainty, we use logical deduction to prove them. So yes, that means we gotta write a lot of proofs, which I know is everyone's favorite. So why do students seem to dislike discrete math so much? I mean, there are a couple of reasons I can think of. One, it completely switches up on us what exactly doing math means. Like, what do you mean it's not just plugging and chugging y equals mx plus b anymore? What happened to the chain rule? All of a sudden, it's not just numbers and letters, but a whole lot of sentences with weird jargon and strict definitions and upside down A's and backwards E's, right? It's just so much writing and reading, and it feels more like a language arts class or a philosophy class than it does a math class. Everything you thought you knew about math now feels like a lie. Furthermore, and this largely depends on what instructor you have and how your course is designed, but the way this class is taught is often not ideal in my opinion. It's often a bunch of random abstract topics chucked at you rapid fire with the expectation to keep up without much emphasis on developing problem solving or proof writing skills. So you just end up lost trying to figure out when to even use proof by contradiction. Meanwhile, your whole life is starting to feel like a contradiction because you're just like, bro, why am I doing all these pointless puzzles? What does this have to do with computer science? I just want to code stuff, right? Now, while both of these are pretty valid reasons to have a distaste for discrete math, from personal experience, I don't think it's quite enough to give it the bad rep it often gets. And I'll tell you this, I remember going through elementary school English class when it was just reading books and writing down main ideas and spelling vocab words and identifying parts of speech in a sentence, right? Like, that was easy. I was cruising through that stuff. Then, boom, high school. All of a sudden, we had to write essays on the books we were reading, using the vocab words we learned back in elementary school. As if this wasn't enough, we were also graded on style and tone and whether or not we understood what the green light symbolized in The Great Gatsby. And I was just so lost. Apparently, it can't be just a green colored light. So my whole world turned upside down. It just got so much harder and so much more complex for no reason. I couldn't believe it, right? So I decided, you know what, I don't like this. I decided English and reading was useless. What's the point? I can speak goodly enough as it is. I don't need no allegory to teach me things I can Google or something. But the truth is, it wasn't even that English class was useless or the fact that it suddenly changed so much that caused my high aversion to it. Because as we all hopefully know, studying English language arts teaches us a variety of useful skills for everyday life. Reading hard texts, critical thinking, organizing and communicating our thoughts and ideas clearly, developing empathy and the ability to understand different perspectives. But the reason I felt so strongly towards English is the same reason I think many students feel the same way towards discrete math. And that's fear. Fear of failure, fear of being weeded out, fear of coming to realize, especially if we have developed an identity of being a high achiever early on, that maybe we will struggle a bit or a lot in order to become proficient in this subject. And our egos may not be able to take that. What if I'm not good enough? What if I'm not smart enough? What if I can't become a good reader or a good writer? What if I'm not cut out for computer science? Rather than address these very real fears and develop the courage necessary to face them, we avoid them by disqualifying ourselves from the start. But true growth requires struggle. It requires failure. Like, dude, I know it's scary. I know it's a hard class. It's supposed to be hard. Because what's the point if it's easy? What's the point if you know from the start that you will succeed without putting in too much effort? I think we often think if we have to put in a lot of effort, if it doesn't come easy to us, then that's bad, but it's not. That's not true. It's okay to be quote unquote stupid. That's how you learn and that's how you grow. Because more likely than not, you will struggle. You will fail. And then you will pick yourself back up and learn from your mistakes and do better the next time. But it's your mindset that will determine whether you enjoy the challenge or whether you suffer through the hardship. But by choosing the latter, you overlook all the amazing consequences that studying discrete math has on you as an individual. And that's what I want to get into next. Studying discrete math, first of all, will teach you how to think like a computer scientist. When you code, you tell a machine what to do, but when you study discrete math, you learn why the code you write actually works the way you want it to. So it makes you reason precisely about steps and conditions and outcomes, the same skill you need in designing correct algorithms and systems. It's also the foundation for many areas of computer science, like algorithms, data structures, networking, databases, cryptography. In fact, many classic algorithms are designed and reasoned about using graph structures. And many of our modern digital security methods actually rely on results from number theory. So, like RSA. Furthermore, studying discrete math will improve your communication skills. Being able to explain complex ideas clearly and rigorously will separate you as a strong professional from a more average one. One of my main goals that I'm actively working on right now actually is to become a more effective writer and speaker and communicator in general. It will also train your pattern recognition skills. You'll get better at looking at the messy details and identifying the abstract underlying structures in the problems you face. It will make you a better problem solver. Because, the whole class is basically just doing puzzles. You'll learn how to break down problems into definitions and construct arguments. You'll learn how to distinguish what feels true from what is true. You'll learn how to spot edge cases and hidden assumptions and logical gaps. And all these are very valuable skills for many fields you could go into, be it software development or research or design, law, whatever. Lastly, and I think this is the most important one, it will make you tough. Because, bro, this stuff is hard. It is really hard. You'll have to work with completely abstract material that don't really have many ties to physical intuition. It will make you stretch your thinking. You'll be forced to sit with confusion and try new ideas and fail and get frustrated and try more ideas and fail again and try again. There's no formula anymore. There's no secret to success. You'll just develop fortitude and resiliency, and that's the key to not only surviving discrete math, but also handling any uncertainty and any challenge that life throws your way. So for these reasons, I truly think discrete math or any proof-based math is a gem of a subject to study, not only for computer science or math students, but anybody. I really do think there's a lot of value in learning discrete math, in learning math. So hopefully this video provided some value to you, and yeah, okay. Oh yeah, that's all I wanted to say.